Shoal. I'm going to moderate tonight through this process. There's some rules we'd like to stick with. One of the big ones that sticks out is be respectful. Come up here, ask your question, and just be respectful to everyone. The questions may not be, what you want to hear, but everybody has their own questions and ideas. There's no stupid questions in this. So ask a question. It's subject to a 2-minute maximum. We want to answer as many questions as possible to get this done. One of the panel members will be subject to a 2-minute time limit. We'll answer your questions. Try not to repeat questions so that we're not asking the same question over and over just to hear the same answer would be great. This is not a debate. We're not here to debate or any of that. It's a question and answer. It's an information session so that people can understand what this system is. So let's try and remember that. You'll be required to leave if you want to be too disrespectful, because there's no place for that. We're all here for the same thing, and that's to get answers. So let's try and remember that. The presentation will end at 8:45. Or sooner if there's no more questions. I mean, there's not much point staying unless they're going to have the dance tonight. Anyway, if I could call upon Kevin Cameron.
Thanks very much. Just to pick up on what was said, We've got a presentation, and we're going to allow lots of time for questions and answers. So we would appreciate if you'd let us go through the presentation, given the number of people here tonight. We think it's a better format. Everyone will be heard. There's no fear of that. Again, my name is Kevin Cameron. I'm the Vice President of Business Development and Government Relations at Sustane. Just walk you through a little bit of what we've got in mind here tonight. The agenda, we're gonna turn the lights down just after the intro. Sure, if that's okay with people. We think it's not going to be easy to see, but yeah, please do. Obviously, talking about why we're here, a bit of background on Sustane and our history. We want to talk about our process, which is not incineration. We're going to explain that from our perspective here tonight. Obviously going to talk about emissions, and again, take any questions that you have. Our plans for this area within Renfrew County. And lastly, we're going to get a third-party view on Sustane from an engineering perspective. And then, as we've talked about, we're going to have question and answers. I'd like to introduce to my left the President and CEO of Sustane Technologies, Peter Vinal. And to my right, our engineering lead from GHD Engineering, Mike Muffles. Both Mike and Peter will describe a bit more of their background and their work when they come forward to speak. I thought it'd be useful. Some of you are familiar with an element of what I'm about to say, but I think it's important that we try to start on the same page, and a little bit of the history of our background in Renfrew County. Maybe if we could, let's silence our phones for the next couple hours. So this started every year, from a marketing perspective, Sustane has put its sole attention around, since 2016, around the Federation of Canadian Municipality Annual Gathering. That's a group based down the road in Ottawa that represents over 93% of the municipalities in Canada. We thought from early days in our company that was a good group to build awareness and rapport with, so we've gone every year. Obviously, the 2020 and 2021 events did not happen due to COVID. But in 2018, we went to a biannual conference, and it was held in Ottawa. It was a Sustainable Communities Conference, and we met the then mayor of Deep River. She was intrigued by what we were doing. She said, I'm going to take it to my county council colleagues in Renfrew County. From there, later that year, 4 months later, FCM happened to have been held in our backyard in Halifax, Nova Scotia. And at that time, 3 representatives from Renfrew County, I think the mayor of Arnprior, the mayor of Renfrew, and the Reeve from Deep River took part in a bus tour as part of the FCM program. So they would have come to Sustane Chester in June of 2018. The next year, both Mayor of McNab Braeside and CAO visited our plant in Chester, followed by MP Cheryl Gallant, who made a visit for the sole purpose of learning more about Sustane technologies. Peter's fellow co-founder, Robert Richardson, and I came here in the fall of 2019, and I believe it was the JAG building where we spoke to a group of 50 to 60 people throughout Renfrew County to tell them where we were at that time. We've made several presentations to Ontario Ministry of Environment, senior staff, to the Minister of Environment, to your local MPP, Mr. Yakubuski. And from a federal perspective, we do a lot of work with some departments in Ottawa. We had Minister Champagne in with his senior staffers for a visit just 2.5 months ago. We're working on a regular basis with the Department of Environment. So they're looking for greener solutions, and we're one of the options that's out there. Why Ontario? Just 3 basic reasons. For some time now, they've been not been granting new permits for landfills, and very, very few for extensions to existing landfills. On average, and this is a very low number by landfill standards, in a province of over 15 million people, you've got just over 15 years of landfill life left. The provincial government for some time now has clearly been embracing new technologies to meet this challenge, and all the while maintain some of the strictest environmental standards in permitting standards in North America, probably second only to California. Lastly, and we're going to come at you with facts from this perspective tonight, we're not incineration. We're far from it. We're going to walk you through our process. We have our own very strict operating standards. The permits that we've received to date are mirrored on Ontario standards in Nova Scotia. Nova Scotia, for what it's worth, is recognized across the country as leaders in waste management. Even in a province like British Columbia, where we spend a great deal of time, repeatedly we hear we're second only Nova Scotia. And that's largely because we were early adopters of green bins and blue bag programs, and very strict landfill liner regulations before the rest of the country. I would say as a Nova Scotian, we're probably resting on our laurels more than we are leaders today, but that perception is out there. Lastly, before handing off, we are fully committed to finding the best possible solution to landfilling, which remains the default alternative to get rid of our municipal solid waste. At that, I'm going to hand it over to our president, Peter Vinyl.
Great, thanks, Kevin, and it's my pleasure to come and speak to you. My goal here really is to just tell the story of what we do and who we are. Can you hear me? You can't hear me in the back? Okay. So my goal is to tell the story of Sustane, where we've come from, how we got to where we are today, and appreciate if you can just, pay attention. Hopefully you can see it. I know it'll be tough down the back, and look forward to your questions when we get into that. My background, I'm an engineer. I grew up overseas, and I've been in pulp and paper for 35 years. Worked from engineer to chief executive in just about every role you can imagine in that industry, including a stint in Ontario. I lived in Ottawa for 3 years. I was the CEO of a company. We bought a pulp mill, reconfigured it. It was down. It was bankrupt. We restarted it, reconfigured the plant, make specialty products, and saved a bunch of jobs. One of my passions through my career has been energy, and how to keep our plants and our industrial facilities in North America competitive, keeping the plants running. To be competitive, you've got to be smarter. You've got to have lower cost and be competitive. And I had a passion for energy and reducing energy costs as part of my role. And so I had a great career. Got sick of working with boards of directors and all of that, and I decided to start a consultancy to help companies be more competitive, particularly around energy. And on that journey, I started to look at different ways of doing that. And my mind got opened up to the possibility of the energy value of waste, okay? Now, I'm an environmentalist at heart. You may not believe that, but I really am. I grew up on a farm in Australia, and our family and the passion for our community was protecting the environment. And so the opportunity for me, kind of late career, to do something and give back is, it's kind of what I live for. It's why I keep doing this. I could be retired, but I've got a passion, and we've built a team that has the same passion, which is to protect our environment and find better ways to continue to have a great standard of living in Canada and build technologies we can export to the world. So back in 2013, I was traveling. I met a gentleman in Spain. I heard about this guy that was cooking garbage. Now, as a pulp guy, I like cooking stuff, right? So cooking wood, dissociating the cellulose, the hemicellulose, and the lignin. And so it tweaked my interest. I had to go meet this guy. So I went to meet him. It was a Saturday. He was at the plant. He built this pilot plant. He couldn't speak any English. I couldn't speak any Spanish, so we struggled. But his son was there, university student, chemical engineering in Madrid. I promise not to ramble this much. I want to get through this in about a half an hour. But I think it's important you understand a bit of the history. So long story short on that piece, I saw a machine that was cooking garbage. Cooking, steam. Not burning, cooking. And so as a pulp guy, I knew that, this is low emissions, everything's enclosed. But what really impressed me beyond that was what was happening. He was taking paper and cardboard and diapers and food and metals, and he was enabling it to be separated and then recycled, okay? So Sustane, we don't call ourselves a waste to energy company. We call ourselves a recycling and advanced recycling company, okay? Because what we do is we take garbage that can't be economically recycled, and we separate it in a way that it can be repurposed for, recycled product, clean fuels, as well as feedstocks. So I couldn't stop there. It was too much of an opportunity. Collaborated with this gentleman in Spain, decided to start a company, and we formed Sustane in early 2014 and developed this concept. We proceeded to do trials, some in Canada, some in Spain, and by 2016 we had convinced ourselves the process had worked. We did large-scale trials of the cooking process in Spain. And when you cook and separate garbage, you end up with biogenic paper, cardboard, food, diapers, plastics. Okay, plastics are everywhere. We recycle less than 10% of our plastics in North America. It's actually going down, believe it or not, in the last few years. What do you do with the plastics? We came up with the concept of depolymerizing using pyrolysis. I'm going to explain what pyrolysis is, but I want from the very get-go to you all to understand we don't burn garbage. We pyrolyze the pure plastic stream after a bunch of cleaning, right? So there's no burning going on, and I'm going to explain all of that. So we came up with this concept to extract the energy from the plastic to be able to give us the energy to run the rest of our plant so that our whole process would be economic. Because if you're going to compete with digging a hole in the ground and burying garbage, you've got to be able to do it cost effectively. So we came at it from that perspective. We raised some money. We found some private investors in Nova Scotia mostly that believed in the concept. We worked with the community of Chester, Nova Scotia to get access to their waste that was going into their landfill. So we put in place an agreement with them to take their waste and leave them in a good financial situation. And we built a plant. We designed and built a plant. And we tried to start it up, and then COVID hit. So it was 2020, we had it built. It took us a bit longer, it cost us a lot more. That happens when you're developing technology on the fly. We started it up, we went into commissioning and started up. The engineers got on planes and went back to their countries, and we were kind of stuck. So it took us longer, it cost more, but by 2022, we've got the plant mostly commissioned. The plastic part is working and working very well. The biomass part is running at part capacity. I'm going to walk through that and explain it. The design concept, and I'm not going to read all these words, I'm just going to tell you, the design concept was, in the beginning, was very low environmental impact, right? So whatever you do with waste, you've got to have low environmental impact. And you've got to eliminate the methane impact from the landfill. So with our process, there is no methane because the garbage never gets a chance to degrade anaerobically underground, right? It comes into our plant, it gets converted into products immediately. I'll talk more about methane later, but that's critical because we've got a warming planet. Most people believe that, and even if you don't believe it, we've got resources that we're going to run out of resources at some point. So putting it in the ground and burying it doesn't make sense. It had to be cost competitive because it's great to have a solution that works in a lab or in a pilot plant, but if it can't compete in the real world with landfilling, it's just not going to happen. So we had to be cost competitive, and the real issues there are energy costs and labor. Combustion, burning garbage, that's just a non-starter. It's not the right thing to do. There's hazardous material in garbage, and plastics, particularly burning, is a really bad idea. I mean, there are products that would be produced by combustion of plastics that you do not want in the environment. The reason that MSW, solid waste, garbage, isn't separated automatically is because it's hard. It's really hard. Like garbage is everything, right? So it's very difficult. The physical form of garbage is roughly 50% biogenic, so like it's paper, cardboard, food, and then everything else, plastics, metals, you name it, it's all in there. So that kind of separation is difficult. And that's hampered by the fact that paper and cardboard and packaging is stiff and hard and doesn't break apart easily. So it's very difficult to get that separation. But the strength of paper and cardboard, and as a pulp guy, I can tell you that strength is hydrogen bonding at a molecular level, right? And I won't get any more deeper in the science than that, but it's hydrogen bonding. And to break those bonds, you can just use heat and steam. And that's what happens when you make paper, right? So we unmake paper in our process by using heat and steam. So we cook it in a closed vessel. I'll talk about how that works in more detail later. There are no emissions from that process at all. And by breaking those bonds, now you've got fibers. You go back to pulp, and at the same time you're cooking, the plastic is shrinking down into little pieces, right? That temperature, we don't melt it. It just kind of shrinks down into balls. It's not melted, it's not burning, there's no gases coming off of it. We picked the right temperature range exactly for that to happen. And that really is the essence of the breakthrough that we have with our process, is that ability to cook using steam with no combustion and enable this separation. It's not as simple as, putting it in a separation machine. We have dozens of stages of cleaning and separation, and they're mechanical, they're not chemical, okay? Plastics are everywhere. So just talk about plastics for a second. I mentioned before, less than 10% of plastics in North America are recycled. That's actually reducing. It's because of the number of varieties of plastic that we have, and that's got to change. And I hope in the next generations we can find a way to change that. We can do better recycling. We can have, EPR programs. There's a lot of things that can happen, and government has a role to play to reduce and find ways to recycle and reduce the use of plastics. And but we are where we are, and we've got to do something in the short term. So if our solution can help for this next generation, that's what we're promoting. What we do with our process is, I say we cook using steam, we shrink the plastic down, we can separate it physically, but it's still not pure enough because there's all kinds of plastics. There's PVC, has chlorine in it. Chlorine's not good. You don't want to expose that to high temperatures. So you've got to get the PVC out. You've got to get the PET out, which is recyclable, has value as a mechanical recycling product. So again, we go through multiple stages of cleaning to do that. I'm going to explain how we do that so that we can make a very clean feedstock that we can depolymerize using pyrolysis to turn into fuels. The other thing I wanted to sort of built into our concept is automation. You don't want people picking garbage. That's kind of demeaning work, and it was never in our vision that we should have, a lot of people doing demeaning work separating garbage manually. This has to be an automated process. And so we've built a high level of automation. We've got, in our plant in Nova Scotia, about 45 high-resolution cameras right through the process and computer controls for every stage. So operators literally sitting in a control room running the whole plant with high visibility. And that helps improve safety and it reduces our operating cost. Again, critical to compete. With our process that I described, and I'll get a bit deeper into it, we can divert up to 90%. You can't practically get 100% diversion. That's very difficult. It's our vision to get to 100, but where we are today, 90% is doable. And the primary products that we make are recovered biomass. Looks like a wood pellet, it's a bit darker. And it's clean. So we're purified. It came from plant matter. It's 90% plus biogenic. The second product we make are diesel and naphtha, which is like gasoline. Okay, so these are clean fuels. They're drop-in, meaning you can put it in your car or your truck if it was diesel. It's not biodiesel. It didn't come from a hydrocarbon molecule. It came from plastic, which is made out of oil. So we're taking the plastic back to oil and avoiding having to take fresh oil out of the ground and refine it. Technology is proven. It's not perfect yet. It's pretty close now. So we're ramping it up in Nova Scotia. And it's a technology that is being developed by practical people. We've got a bunch of engineers, but industrially hardened engineers from pulp and paper and energy. And frankly, the reason we've been able to bring innovation to the waste space is because we're not from the waste space. We're a bunch of technical people from other industries that have looked at this problem and said, we've got a solution, and it's not simple, but it's a solution that we can make work, and we've made it work. I talked about our first plant in Nova Scotia. We can talk about that later. From a climate perspective, I believe in global warming. If you don't, that's okay. We can't afford to be, putting resources in the ground that we really need in our society. And so we come at it from both directions. We're conserving waste with our process, but we are eliminating a massive amount of CO2 equivalent. So for every ton of waste that you divert, that would go into a landfill that now goes into a Sustane process, you're going to reduce CO2 by somewhere between 2 and 3 tons. Okay, depending on how much methane maybe you're extracting from your landfill. In many landfills here, that there isn't very much. So the opportunity to really kind of get leverage on CO2 and global warming with what we do is very high. So our vision is this sort of waste platform. I hate to use buzzwords, but the platform simply means we've got some flexibility about what we can put into our process, and we've got some flexibility about what we can get out of the process. that flexibility is driven by, okay, what does the garbage look like? Do you have green bin programs? Do you do source separation of organics? How much plastic is recycled already? These are all things we have to look at before we would consider putting in a plan, right? So we need to know what's in your garbage. And we do that by studies. Essentially, there's, companies that can, unload trucks, pick through, and do statistical analysis and give us some data. In general, our main feedstock is regular garbage, curbside, that goes to the landfill. We don't touch recyclables, so if you've got blue bin programs or you're recycling stuff, great, go for it. That's what you should be doing. There are some cases where we might argue it's not economic to recycle some of the things that we're recycling. And frankly, and believe it, we see that a lot in Nova Scotia, which is one of the leaders, as Kevin said, in recycling. We see what comes out the back end of the recycling plants and goes to the landfill. We see it every day. And we take it and we put it in our plant and we recycle it, right? And so that's the flexibility point. We can take some of these streams that have got to go to a landfill because recycling's failing, or we can take organics as well. We're kind of ambivalent, and that's a discussion we'll have with the community. What makes sense for you? Do you want to have your organics go to a composting facility? Do you want to have it come to a Sustane facility? It'll work either way for us. The little kind of bluish box in the middle there that you can't see, that's the Sustane thermal part. So that's the part where we're doing the cooking, and then there's a whole bunch of cleaning stages. I'm not going to go through our whole process, but there's about 20 different separation and cleaning stages. But after we cook the garbage, and of course we've shredded it up, we don't just throw it straight into a cooker, it gets shredded up to 3" and minus. We pull out, big metal so we don't damage things, and then we just cook it. And it's in a closed vessel. We use steam at a certain pressure and temperature, and as I explained before, it causes the fibers to kind of open up and break those hydrogen bonds, and the paper goes back into pulpy material, and the plastic shrinks down. This all happens over about an hour. So we cook for about... Can you hold the question? I think if we start answering questions, I may not stop. It's a great question. I'm happy to come back to it, okay? So we use steam, and we get broad separation into a plastic stream and a biomass stream. We clean the biomass, we make pellets, and the plastic goes through 10 different stages of cleaning to get to polyethylene and polypropylene. Pure polymers with no contaminants, okay? It takes a lot of work, believe me, to get there really clean. And why clean? Because we're going to use a pyrolysis process to vaporize that plastic and then condense those vapors into liquid, and that liquid is diesel and naphtha, okay? Or diesel and gasoline, let's say that. And I'll spend a bit more time on that because I think it's important and very relevant that you understand what that means exactly. Our first focus as a company was fuels, taking waste and making fuels, okay? Biomass for combustion, diesel for combustion or transportation, put in your truck. But the world is moving on. More and more we hear, well, do we have to burn things anyway? What about solar and wind and renewables, right? What do we have to burn? And so we've started to look at alternatives, and we've found alternatives. So in the case of the liquid fuel, the diesel and the naphtha, the industries came to us. There's a big push for circularity in plastics. I talked about less than 10% getting recycled. That's because recycling systems don't work well, right, globally. They're all different, and they don't work well. But there's a thing called chemical recycling, which is to take that polyethylene and polypropylene and turn it into naphtha, and then turn that into ethylene, which is a building block for plastic. And so that's what's happening here, is that these petrochemical companies are coming to us and saying, gee, we hear you make naphtha from plastic. Can we have some? Can we try it? And they tested it, and they like it, and now they're saying, we'll take it. We would like to take your products so that we can circularize plastic. So that's the pathway that we are really enthusiastic about. It's okay to make a fuel that replaces a fossil fuel so we can conserve and keep, keep our oil in the ground. But that's better if we can circularize it, right? On the biomass side, so that's happened already, and that's happened like years before we thought it would, which is exciting. So we really are excited about that. We've got opportunities to literally sell all of that product into circular plastic. On the biomass side, burning biomass is okay because it's carbon neutral, okay? Meaning it came from a tree, it took in carbon dioxide when it grew, you burn it, it's gonna go back, and so you're neutral. Many would argue that that's great, and some would argue it's not good. It's a whole lot better than burning oil or coal, for sure. However, there's other pathways that we've been pursuing. We're working with a company that has developed a process to make a liquid fuel out of that biomass, and that's been successful. The trials have been successful. We're working on an RNG option, renewable natural gas from that. Again, very low carbon products. And then a future opportunity, which we are working on aggressively, is actually agriculture. So it's the ability, our biomass is so clean, we're meeting all of the federal standards for agriculture to use it as a biofertilizer. And so that's future. We're not there yet. We're working with CFIA, getting our registrations, and working with farmers. We've got a very large agriculture company and food company in Canada that is keen to work with us on that. So that's the future. I don't want to spend much time on this other than just to talk a little bit about the core innovations with this process. The steam cooking, we'll come back to the question on steam, I think. Plastic circularity, purity in the products, energy self-sufficiency and automation. So those are things that are fundamental to our process. I want to do a little deeper dive, and I apologize if I get a bit technical here. Bear with me. I wanted to do a bit of a deeper dive on thermal processes, okay? Because, if you go on the internet and look up pyrolysis or, gasification or incineration, it gets really confusing really fast, because these things kind of overlap. There's different feedstocks. So pyrolysis is many, many different things. So I want to just go through it. So let's compare some technology. So on the left would be what we are doing at Sustane with the plastic. And keep in mind, this is not garbage. This is the less than 10% of what's in the garbage. So after it's separated and cleaned, we get polyethylene and polypropylene. Okay? So we put it into a vessel, we heat it up, it's a closed vessel, we heat it up, and that plastic is vaporized. So it turns into gas, right? So that gas then goes to a scrubber, clean it, and then we condense it, and 85% roughly of that gas condenses into liquid. We do it in 2 stages. The first stage makes diesel. The next stage makes gasoline or naphtha. And then a portion, like 15%, stays as gas. And it's like propane. It has very similar composition to propane. It's a clean gas. But we've scrubbed it. So we've made sure that it is clean. And then the diesel and naphtha, we filter that. It goes through an ultrafiltration process using a special media, and then it's fully refined and ready for use. And it has lower contaminants than what would be road diesel or gasoline. We use a portion of the gas, roughly half of the gas, the 15% gas, the propane, to heat the reactor. Okay, so that's our emissions from the plant right there. Is that portion of the gas which has been scrubbed that goes to heat the reactor to vaporize the plastic in an enclosed vessel, so there's no other emission other than the combustion products, okay? So that's what we do. We're not burning anything. There's 0 oxygen in there, so it's not combustion. It's simply heating it up and gasifying it. Gasification and combustion are quite different. So gasification is a technique that's sometimes used for waste, for garbage. It's used for biomass, wood, different things. And there you are operating, you're putting some oxygen in, but it's deficient. So it's operating with a heavy oxygen deficiency, and you're hotter. So instead of 500 degrees, roughly, you're more 1,000 degrees, maybe up to 1,200 degrees. You've got partial combustion going on, but basically you're making gas, so carbon monoxide, methane, and some other trace gases. And then you're going to burn that, and you're going to make heat or energy. Okay, so we're making fuel in our process. These processes are making energy. And then you've got a scrubber, and then you've got some emissions, right? Because scrubbers are not perfect. So when you are burning, and big distinction is, when you're burning garbage, you're burning a lot of things that are really bad, like plastic. So you've got to deal with, SO2 and NOx and particulates. And so for that reason, the scrubbing is not as efficient. So, even the big incinerators, like, the one in Toronto, they have some emissions. It's not perfect. Pretty good, but not perfect. Combustion is simple burning. You run with an excess of oxygen, so now you're completely converting the fuel into energy. And again, you can mass burn garbage. We're not believers in that. And as I said, burning plastic is a bad idea. How do we ensure that our plastic feedstock is clean? So the stuff that's going into the pyrolysis part, how do we make sure it's really clean? So we have 10 stages of cleaning and separation to do that. I'm not going to tell you what each of the 10 stages are, because that's a bit proprietary, but I just wanted you to know that they are there. And if you walk around our plant in Nova Scotia, you could count them. And by the way, if any of you folks ever out in Nova Scotia, feel free to reach out. We do tours, and we've got communities, groups come through, schools come through regularly, and anybody's welcome. So I talked about the CO2 reduction. So CO2 is, known global, the driver of global warming. So CO2 levels in the atmosphere are at, record high levels, and that correlation is very strong. So why is that? Well, because we burn stuff, and we've been burning stuff for quite a while, and so there's, CO2. And the stuff we burn is fossil, meaning it's come from, way underground, and that carbon has been trapped down there. Now we're burning it, and that carbon is being released. If we didn't burn it, the carbon would stay down there. So that's the main thing. Methane is pretty much the worst greenhouse gas. So we talk about CO2, which is coming from burning stuff. Methane, a ton of methane is on a 20-year warming basis, on a 100-year warming basis, is about 25 to 28 times worse than CO2, right? So you get 28 times the warming effect for a ton of methane versus a ton of CO2 on a 100-year basis, okay? Some would say we don't have 100 years to address the climate crisis that we have, right? On a 20-year basis, it's 80 times, okay? So we won't talk about that, but that might be a multiple you could use. A few years back, Sustane, we were working with the federal government, Sustainable Development Technology Canada. They reviewed our technology. They gave us a grant because they were very impressed with it. And they could see the potential for CO2 reduction. And they said, yeah, we like your numbers, but you need to prove it. And you need to hire a consultant that's an expert in that space. So we don't just trust you. We want to get a third-party group to come in and do it. And so we had to use their consultant EnviroAccess. They did life cycle analysis of our process compared to a landfill. And without getting into the details or each bar here, there's kind of three big things. I'll just point at them. Sort of three big things that for a typical community of, say, 175,000 population, 70,000 tons of MSW, you're going to reduce a net reduction of 175,000 tons of CO2. So it's, 2 to 3 times the number of tons of garbage that you're actually processing in the plant. Why is that? Well, the big bar there is 123,000. That's elimination of the methane at the landfill. So that's not landfilling, not allowing organic matter to go underground where it'll degrade, anaerobically and make methane. This bar here at 26,000 is recycling of materials. So if you mine materials in Africa and ship it to Egypt to smelt it and then off to China and then back, that's a lot of carbon, right? If you can just recover that metal right here and use it right here, it's much lower carbon. So that's what that is. And then if you can replace fossil fuel like coal or oil with our biomass, that's another chunk, that's another 30,000 tons. So that's how you get up to the 175. But we're not perfect. We need a bit of energy to run our plant, right? We have to burn some fuel. We've got to make some steam. We've got to dry our fuel. And we use some of our fuel to do that from the plastic, which makes our process economic. But those are the red bars there. So just to give you a perspective, see the little red bars there? That's the energy that we are using in our process relative in CO2 terms. So in terms of carbon being put into the atmosphere, so the net 175 is the green bars minus the red bars. I want to just spend a little time on emissions, because I know that's a very sensitive subject, and it should be. And so I'll just kind of walk through, in what happened in Nova Scotia with our environmental permit, the nature of the emissions, and also talk about, what it might look like for a project here in Ontario. If anybody has really detailed questions, Mike is here from GHD. Those are the guys that are really the experts in the permitting process and the regulations surrounding emissions in plants like this. So in Nova Scotia, we had two environmental permits. The first one was for the cooking, I call it cooking, but it's the thermal hydrolysis, it's the steam part. And so it was basically from the tipping floor where the garbage comes in, the cooking, all the screening, separation, and to make the biomass and make the clean plastic. So there's a permit for that. And it was very straightforward because we had virtually no emissions there. So that was pretty straightforward. The second permit was for plastic pyrolysis because it's a very different and new technology. It hadn't been done in Canada before, first of its kind, and so as you could expect, the regulators, Nova Scotia Environment, were cautious. And it took us 3 years of back and forward, and frankly educating them and us learning what the requirements were. And it was a good process. It was painful, and it cost us $500,000 to go through it, but we learned a lot, and it was necessary for us to learn and for them to learn. Again, I'll just repeat, it's less than 10% in the garbage that goes through that pyrolysis process after extensive cleaning. So what we were required to do in Nova Scotia was, and I guess, Mike, you would say this is what has to happen for every project, is extensive process modeling, which means that you've got to, go to consultants that specialize in saying, okay, for this material coming in with these potential contaminants, going through a process like this, like has been described, the pyrolysis process, and using very conservative assumptions about, things that could happen. You've got to make sure that you assume they go to the worst possible place that'll have the worst consequence for the environment, right? So you go through a process like that, which frankly is, was a little frustrating and time-consuming, and some of the assumptions were really conservative. But that's okay, because you want to be that way, because you don't want to, make a mistake and have an emission that exceeds, the science limits that are imposed. So we went through that process modeling, and I wanted to note that Nova Scotia, I think Kevin, you mentioned that Nova Scotia uses Ontario standards for emissions. Because, I think there's more scientists here, a bigger population, and so those are some of the strictest in North America. So just bear with me as I go through this piece. So in that modeling, which again is based on theory and the worst case, 40 potential contaminants were identified as things that should be looked at, right? So things that could, come through the process, get into the air after going through our pyrolysis process. 4 of the contaminants were modeled to exceed the regulatory limits. What does that mean? What it means is that, based on the worst case of contaminant levels, which are frankly far above what we actually have, and all of these conservative assumptions, 4 of those 40 came out over the limit, right? So what you have to do then is you have to mitigate. So you go back and forward with the department and the modelers and say, okay, well, we can put the scrubber in. Okay, we can change the process this way. And that's what we did. So we agreed to install air pollution control systems on the gas stream and also cleaning the fuel such that we came in well under, order of magnitude under the emissions, even on that conservative basis. The net result of all that is actually we make really nice clean fuels. And, there's you don't see anything in the stack at all. We have one stack. Essentially, it's a flare stack. And the final point, I think, would be it's not a one and done. That's not the end of the process. That's actually the start of the process, right? Because now we started the plant up. We're ramping it up. Now we have to collect the data to support that. So the collection of the data is extensive, both on the feedstock, the plastic that's going in has to be monitored and reported, and the stack testing has to be done. So all those 40 things have to be monitored, right, on a periodic basis. And so you have to prove that you're achieving those standards at full operating rates. Okay, so that's the end of the technical part, and I'm sure there'll be more questions. So what about McNab Braeside? What would be our goals, Sustane, in coming to a community like McNab Braeside and Renfrew County? Well, it would be to build a showcase facility. We built one plant. It's a good plant. It's not perfect. And we're going to improve our plants. And that's, so that would be a first in Ontario plant. Reduce greenhouse emissions by around 150,000 tons of CO2 per year, which is over 50,000 gas-powered cars, according to the Government of Canada. Transform that lowest value landfill plastics into 4 million litres of clean diesel and naphtha for either as a fuel or as a feedstock to make more plastic. Roughly 25 jobs in the plant. They'll be pretty skilled jobs. We typically hire power engineers. We like to hire young people and train them. And so we have a mix of, sort of mid-career and younger technology-oriented jobs. Where are we in the process of looking at a plant here? So we have a non-binding memorandum of understanding signed. It doesn't commit this community in any way, other than to give Sustane an indication of interest so that we can justify putting some effort into it, right? So now we have to sort of move forward on, okay, what does the project look like? Do we have the volume? Let's look at, siting and environmental permitting and start that process to develop a potential project. We're evaluating different sites, suitable sites for the facility. The landfill has some advantages. There are definite advantages of being at a landfill. We're commencing the preliminary engineering, site evaluation, and the permitting process. Those are long, they can take a while to go through those processes, so you have to start. Just like building a new landfill takes a long time. I think building a new landfill takes longer to get the permits than or maybe order of magnitude, or maybe similar magnitude to this. So we're working with GHD. I'll introduce Mike here in a minute to kind of give his views and impressions. And we're evaluating different offtake options for the biomass product. We've got a number of quite good options that we can pursue. For the diesel and naphtha, it's pretty high demand, so we don't expect any issue in finding markets for that product. Okay, that's my part. I'm going to hand off to Mike and talk to you later.
Good evening. So just very quickly, I know Peter went a little bit over the half hour that was promised. So my name is Mike Muffles. I'm an engineer with GHD. I have 18 years of experience in agricultural solid and municipal solid waste. Most of the last of the 9 years of my work has been with helping municipalities develop, and build waste plants, City of Toronto, City of Halifax, and some others. So we've been engaged by Sustane to help them deploy projects in Ontario, and so we're just on the start of that path. So I only had really a couple things to say. GHD, we're an engineering consulting company, offices globally. There's a bunch of information here in the slides about some of the projects we worked on. So what I did want to reiterate is that this technology is not incineration, right? When you look at the products, when you go through the slides and look at the products that Sustane is making, they're making half of what's the output of the plant is that pellet product, and then there are oils, and then the metals that are recovered, the other plastics that are recycled. And so when we look at a hierarchy of waste management options, right, it's falling under the recycle. We're taking the waste in, MSW in, Sustane is, sorting it into different products. A small percentage, 3% of the weight coming in goes out as gas that's used back in the process, so that's the energy component. So for energy to waste, it's only about 3% by mass, roughly. And then about 10%, right? So of what's coming in is being disposed of, right? So there's no recycling technology that recycles 100% or recovers 100%. So this technology, the mass balance, looking at the numbers that are generated from the Chester plant in Nova Scotia, it's about 90%. So, and the last thing that I wanted to say, just that we got to know Sustane. First, we were hired by another client, actually a potential investor in Sustane, to do a technology or technical due diligence as part of their due diligence in their financial decision. And so we got the opportunity. There was a team of us that went out to Chester. We got to climb all over the equipment, look at all of the technical reports and data, and then provide a report to the client about the status of the project, right? We identified so a lot of good things about the plant and also a number of issues. As Peter mentioned, it's still in ramp up. It's not fully operational yet. And so those issues they're working through. None of what we said in the report were a surprise. The last thing I did want to say is, I mean, I think I am, and GHD is, we're pretty excited about working with Sustane. We think this is a promising and emerging technology. There's a lot of these different kinds of quote-unquote energy from waste technologies out there, and we've evaluated a number of them on behalf of SDTC and other clients across the world, and this is one of the ones that when we sit down and look at it, we're pretty excited about it. It's not fully operational. There's a few technical challenges that have to be worked out that they're working on, but there's definitely some promise here. So with that, I think I'll stop and open the floor to questions.